Greetings, everybody, and welcome back to Introduction to Economics, um, courtesy of Mr. Miller's Greenville High School. Um, we are going to go through um, the first part of equilibrium, price, and quantity. In this video, we will be talking about part two in the next video set to publish in a couple of days. But many of my students have been asking me, hey, what's the big deals? We get these price schedules, supply schedules, demand schedules. We plot the line on the graph, demand curves, supply curves. We shift them left, we shift them right. So what? So I got a pretty picture to look at. Well, the pretty picture, we've talked about supply separately. We've talked about demand separately. What we're going to be doing with equilibrium is we're going to be looking at plotting both the supply curve and the demand curve on the same graph. Now, as you know, the supply curve is going to run lower left to upper right. We know the demand curve is going to run lower right to upper left because as price goes up, supply goes up. As price goes up, demand goes down. What we're going to look at with equilibrium is we're going to look at that intersection point. And that intersection point is called the equilibrium point. And for lack of a better term, the equilibrium point is the focus around which the entire market economy functions. It's the eye of the hurricane. It's the focus of the circle. It is the center of the earth. It is everything about a market economy driven by that equilibrium point. So we're going to be looking at a few definitions, and we're going to be talking about how the equilibrium point is determined and what it actually means to both consumers and producers. So as with anything, when we start a new topic, we talk about basic definitions. And the basic definitions that we're looking at start with equilibrium price and equilibrium quantity. Together, the equilibrium price and the equilibrium quantity are what define the equilibrium point. So equilibrium price is the market price where the quantity of goods supplied is exactly the same as the quantity of goods demanded. Now, why on earth would I call it the equilibrium price if I'm talking about the quantity? And the answer is because I have to have the quantities to be able to graph the price. So as we see with that supply curve, if I start down here with a very low price, my suppliers are not incentivized to produce very many products and make them available for sale. As the price goes up, the quantity supplied is going to go up as well. With my demand curve, exactly the opposite is true. If the price is very, very low, quantity demanded is way over here on the right. And as that price increases, demand starts to drop off. So when I look at the crossing of those 2 points, the equilibrium price, which is on my y-axis here, is based on where the quantity is the same supplied and demanded. So if I draw that price line from left to right towards the intersection of my 2 arms here, the quantity demanded and the quantity supplied exactly equal each other at that equilibrium point. So the equilibrium price is the price at which supplied to quantity and demanded quantity are exactly the same. Equilibrium quantity simultaneously equal to both the quantity demanded and quantity supplied. So when the quantity supplied is the equilibrium quantity, that means the quantity demanded is going to be the same. And this is determined, as I've said, in the market graph. The equilibrium quantity is the intersection of that those two curves, and it equates to um, the quantity supplied and the quantity demanded being exactly the same. So in this case, everything is defined off of the actual quantities, even though we're talking separately about an equilibrium quantity and an equilibrium price. So if you remember back to the lessons on supply and demand, you remember that we dealt with supply schedules and demand schedules. And the schedule is nothing more than a table of the price points shown here in the left column and the quantity shown here in the other two columns. So when we look at an equilibrium schedule, all we've done is we've taken the supply schedule and the demand schedule and we've pushed them together. If you remember the examples I used in my previous videos, I had a notional product that the price points ran from $10 all the way up to $100. And these are the actual supply tables that I pulled from my earlier lessons. So the quantity supplied is a direct relationship with price, which means as price increases, quantity supplied increases. My quantity demanded is an inverse relationship, meaning as price increases, quantity demanded decreases. And I just put them all in the same table. And then I can build my market graph, my market curve from that combined schedule. And this is what it looks like when I plot those two curves out on the same graph. So here's my supply schedule. $10 low supply, $100 high supply. And then my demand schedule marked with D, low price, high demand, high price, low demand. And you can see, because the supply curve is always going to go lower left to upper right, demand curve is always going to go lower right to upper left, they have to intersect at some point. And so we look at that intersection point and we can see exactly what the price, the equilibrium price is, and exactly what the equilibrium quantity is. And so when we look at the equilibrium price, that intersection of the supply and demand curve cross right at $55. So $55 is where the supply, quantity supplied exactly equals the quantity demanded. Because if I add my quantity mark to it, look, the equilibrium quantity is 43. You ask the question, is it 43 demanded or 43 supplied? The answer is yes, because it is the 43 point on both this curve and this curve. So quantity 43 at $55. Remember, you always have to have a price point to determine a, you always have to have a price in order to determine a price point. So it's not just the quantity of 43, it's a quantity of 43 at $55. Now, something else that we talked about in our supply and demand blocks is we talked about factors that cause demand curves and supply curves to shift. 4 factors that will cause a demand curve to shift left or right, and 8 factors that will cause a, 4 factors that will cause a supply curve to shift left or right. And remember that when a curve shifts, it's something other than a free market factor that is causing that demand or that supply to shift left or right. It's something outside the control of the people that are supplying or consuming the goods. So it's not that demand has changed, it's not that supply has changed, it's that the quantity demanded or the quantity supplied has changed at every price. So every price point, in this case, the demand is shifted left. That means demand is less at every price. It's shifted left at $10, it's shifted left at 20, so on and so forth, all the way up to shifting left at 100. If the demand had only changed at one price, I would have to go back in and change the shape of my demand curve. But because demand has changed at every price, my entire curve shifts left. So now when that happens, you would of course expect the equilibrium quantity to also shift left, and it will. But remember that it's not just the demand curve that determines pricing. It's where that demand curve intersected the supply curve. And when my demand curve shifted left, the price did not stay the same, the equilibrium price, because the intersection actually moves down the supply curve. So not only is my quantity demanded, or in this case, my equilibrium quantity, not only has it moved from here to here, left on the quantity scale, but my price point has also moved from here to here on the y-axis. So I wind up getting both a new quantity and a new equilibrium price. In this case, it dropped from $55 to $47, and my equilibrium quantity has dropped from 43 to 37. That point, that equilibrium point, has affected both the equilibrium price and quantity. Now, this phenomena happens no matter which curve is shifting and no matter whether it shifts left or right. And we're going to look at a couple of examples because it's easy when one curve shifts. We're also going to look at some examples of what happens when both curves shift simultaneously. So, hey, demand curve shifts right. Look at that. Not only has my demand, my quantity equilibrium point shifted right, as you would expect, because your demand curve moved right, your quantity is going to move right. But because the intersection has slid up the supply curve, I have also come to now a new higher equilibrium price of $63. And lo and behold, a new equilibrium quantity of 47 versus the old equilibrium quantity of 43. So again, right shift on the demand curve, both price and equilibrium quantity increased. Let's look at what happens when the supply curve shifts left. Now, we know the same thing is going to happen. Supply curve shifts left. We can automatically predict that supply is going to go down. But unlike when demand shifted left and price went down, in this case, fewer items supplied at every price caused the curve, the intersection, to slide up the demand curve. So demand hasn't changed at any price. But because the supply has decreased, that means that proportionately there is now less supply for the same demand, which means the price can go up. People are going to be willing to pay the higher price because they know that they may not have the opportunity to purchase at that lower price. So they'll go a little higher. So we see that new equilibrium price jump from $55 up to 63 with a left shift in the supply curve. And the new equilibrium quantity is dropping to 37. Left shift on a supply means less supply at every price. Same thing if the supply curve shifts right, there is now more supply at every price. The equilibrium quantity is going to rise, but the equilibrium quantity is going to rise because the equilibrium price is now lower. And as that price slides down the demand curve, the people who were not willing to buy here at 55, who are willing to buy here at 47, come into that marketplace. So I have increased the number of items I can sell by increasing my demand. And so that new equilibrium price, 48 bucks, has resulted in an increase in equilibrium quantity from 43 to 47. So $7 drop in price, increased quantity demanded by 4, which means there were 4 people willing to purchase at 47 or $48 who were not willing to purchase at $55. New equilibrium quantity, new equilibrium price. Simple, right? There is a video embedded behind this picture, and I will post the link to that video on the classwork when I post it in Google Classroom. And it is essentially a much simpler and succinct explanation of basically what I just told you, but probably in a way that's easier for you to understand. So why do I care about the equilibrium price and quantity? Well, I care for a couple of reasons. First of all, equilibrium price. Let's look back at total revenue. Total revenue is calculated by multiplying the quantity demanded, which is essentially the number of items that I can sell at any given price. Quantity demanded times price equals total revenue. Now, the supplier has a goal not to make more per item or make less per item per se. The supplier's goal is to make the maximum total revenue possible. And this is why suppliers are very, very concerned with where that equilibrium point is, because that equilibrium price is maximum revenue for the supplier. Now you might say, but Mr. Miller, if I increase the price, I still am selling quantity at that higher price. And the answer is yes, you are. But if you remember nothing else from the worksheets that we did on total revenue calculation, you learn that depending on how steep or shallow this curve is, a higher per item price might actually result in a sharp enough drop in quantity demanded to where your revenue at the higher price decreases. So I might make $10 more an item, but I might lose 50 customers at the higher price, and my total revenue decreases rather than increasing. So we look at this point here. This is where every person who is willing to pay this price was able to purchase at this price. 43 people wanted that product, and the suppliers produced 43 products. And so each person bought one product, each person was happy, and the price was $55. So the supplier sold every single one of his products at $55. If he'd have made 50 products, he would have only sold 43 of them, and he'd be sitting on 7 that he didn't make any money off of at all. They're now occupying his warehouse, taking up storage space. And if you remember, elasticity of supply, one of the factors that elasticity addresses is the amount of storage space available. So if he's got tons of storage space, it just means that he's got inventory he might be able to sell in the future. But if he's limited in his storage space, he's now got stuff taking up that extra space. So he made 50 items, couldn't sell them for $70. He sold 43 of them. Actually, let's see, at $70, he sold 30 of them at $70, but he made 50. So the gap between that amount sold, the 30 that he sold here at $70 versus the 50 that he manufactured here at $70 is called surplus quantity. He's not making any money off of those extra items. So what's going to happen? Well, he's either going to hang on to them until there's a shift in the demand curves, or he's going to suck it up, drop the price, offer them at discount or for sale, and see if he can salvage some income out of them that way. But when we look at the equilibrium price, because if he sets his price below that equilibrium price, he's able to sell more, because look at all these people over here that want to buy it. But he doesn't sell more because he didn't make any more. He only made 20 items for $20. So when we look at that, he made a certain revenue that's down here on the lower end. Let's picture revenue as a bell curve. Okay, down here on the lower end of the bell curve, he made too few items because the profit just wasn't worth it. Sold them all, but he didn't make much revenue. Over here on the high end, he makes a bunch more of the items, but he's not able to sell as many at the higher price. So that's this side of the bell curve. He's made a lot of items, but because the price is higher, his revenue is on the back side of that bell curve. So at the equilibrium point is where he has charged low enough to get people to purchase and made enough of the product that he sells everything he makes. And the apex of those two curves meeting, those two plots, is the equilibrium point, which means he has maximized his revenue. And that's why it's important to the seller to meet that that equilibrium price. In a couple minutes, we'll talk about why it's important to the consumer. But that surplus quantity from plotting the price too high, just bear in mind, is inventory that he cannot sell at the price that he is asking. Now, as we just talked about, if he sets the price too low, we experience a quantity shortage. So the suppliers were willing to set a price, in this case $32. They were willing to set a price of $32 or $33. But at that price, they were only willing to make about 26 or 27 items. People were willing to buy 53 items, but only 27 were available. So we have a shortage of goods out there on the market. So people are grumbling. They're not happy because they weren't able to buy the product they wanted at the price that they were willing to pay. This is a measure called customer satisfaction. And again, let's look at that bell curve. When we look at the low price, there are a lot more potentially satisfied customers because customers are happy when they pay less money than they're willing to pay. They've gotten a good deal. But because the supply will not satisfy every customer, your customer satisfaction rate is on that back side of the bell curve. It's down here at the bottom. Now you look at the other side of the curve where there's plenty of goods and services to go around, but the price is set so high that very few people are willing to pay that higher price. The people who are willing to pay the higher price will go ahead and purchase, and they're satisfied. So they're up here near the top. But all those other people who are looking at it going, I really, really want that product, but I'm not willing to pay all that extra money for it, they're down here on the unsatisfied part of the curve. So the people who are satisfied because the product was available, and the people who are satisfied because the price was at or below what they were willing to pay, again, meet on that bell curve. And the top of the curve is the equilibrium price. So if I'm selling too low for equilibrium, I have unsatisfied customers based on a quantity shortage. If I sell too high, I have unsatisfied producers due to a quantity surplus. And this is where we describe those basic definitions. So a consumer surplus is when consumers pay a lower price than the maximum they are willing to pay. Producer surplus is when producers sell at a higher price than the minimum at which they would be willing to sell. And we call the combination of the two, if you add consumer surplus to producer surplus, you get what's called an economic surplus. And that's a number used by economists to measure the health of the economy. Let's look at how that graphs out. So consumer surplus, remember consumers are the ones who are happy because they're getting the product for at or below their price. So this line, my demand curve, equates to the price that each consumer is willing to pay. So let's say this group of 10 people up here that are willing to pay $100. If the price is at $55, they're happy because they paid less than they were willing to. And I'll give you an example of that. One year for Christmas, I bought my wife a Volkswagen Beetle convertible off of eBay. And if you're familiar with eBay at all, you know that if you want to bid on something and you're worried about getting outbid, what you can do is you can go into an auction, you can actually set a number, the maximum amount of money that you are willing to pay for that product. And what will happen is, here's your bid, okay? And somebody comes along and they outbid you. If you've set a maximum above that outbid, eBay will automatically bid the next unit up. You get outbid again, eBay will automatically post your next bid up to the maximum amount that you have said you're willing to pay. So I found a bug that I really, really liked. And I decided that the maximum amount that I was willing to pay for this bug was $8,000. So I went ahead and I plugged in a maximum bid of $8,000. And the current bid was at like $1,500. And so I checked back every couple of days, and the bid was always higher and higher and higher, but nobody else outbid me. And I got it at $5,450. So I was willing to pay $8,000. Okay. I got it for $5,450. I fell into this consumer surplus of customers who were happy because we paid at or less than our maximum price. Now, the producer surplus, you can see, the supply curve is the minimum price at which the supplier is willing to sell a product. So as long as they sell at this price or higher, we are said to have a producer surplus. And you can see the 10 suppliers who are willing to, or the 10 products that the supplier was willing to produce at $10. If he sells them for 55, he falls into this big purple area of producer surplus, and he's happy. This guy, he's able to produce 20 at $20. So the minimum price he's willing to produce that many for is $20. He's getting 55 a pop. So they're able to sell it at a price higher than what they were asking. The consumer is willing to purchase at a price lower than they were willing to buy. And the two shades in that graph added together equate to the economic surplus. We look at the change in consumer surplus to measure changes in price and income. So this is going to get a little confusing because of the way the minus signs work, but try to follow. Change in consumer surplus is measured as the new price minus the old price changed to a negative number. So let's say my new price is 5 and my old price is 3. P1 minus P0, 5 minus 3 is a 2. And I change the sign because I've got a minus in front of the parentheses here. So my number is -2. -2 is bad because that means there was a price increase to the consumer. But if I look inside the parentheses here, going down is good. So P1 minus P0, that went up. It went from $3 to $5 a unit. Up is bad. Down is good. Down is good for the consumer. So the way that they do that is they say that negatives are generally bad and positives are generally good. So by changing this to a negative number, we show that the consumer surplus, the change in consumer surplus in that example is a -2. Negative is bad, therefore it was bad for the consumer. So if the change in consumer surplus is positive, if the price has dropped, the price change is said to have increased the individual's welfare. And if the price change in consumer surplus is negative, meaning the price has increased, the price change is said to have decreased the individual's welfare. So a positive change, good for the consumer. A negative change, bad for the consumer. Change in producer surplus, meaning producers were able to sell for a higher price than they were willing to accept, measures the health and well-being of production. So when we look at that, it's the exact same formula, except we take the new price, we subtract the old price, and we just leave it the same. So P1, new price, $5, old price, $3. 5 minus 3 is 2. 2 is a positive number. The price has gone up, so up is good for the producer. Okay, but because I'm sorry, I should new price 5, old price 3, so I got a positive 2. Good for the producer. So if the change is positive, which means the new price is higher than the old price, then the producer surplus is a positive number, and the price change is said to have increased the producer's welfare. Likewise, if the old price is $5 and the new price is $3, meaning in order to sell the product, I had to lower the price. That's a negative change in producer surplus, and that change is said to have decreased the producer's welfare. So prices go up, it increases the producer's welfare, it decreases the consumer's welfare. Prices go down, increases the consumer's welfare, decreases the producer's welfare. And the percentages in those changes are one of the entering arguments that economists use to measure the health of the economy. So with that, we are done with part 1 of equilibrium pricing. So you should see the assignment that has the equilibrium pricing worksheet. You should be able to use the information in these slides, which are available in a PDF format in the classroom. So you can look at the slides without having to listen to me drone. Or you can go back and listen to key parts of the video if you want explanations for the various graphs that we just reviewed. But you will need to be familiar with that material before you'll be able to complete the worksheet. So if you have any questions at all, make sure you email me or send me a private message, and I will come up and assist you with the information. We may even go into Google Documents and look at actual graphs that we can create using the supply and demand tables in the worksheet. So with that, part 2, where we talk about the government intervention that constitutes price ceilings and price floors or quotas on limits on production, will come down in a few days. So look for that video as well.